Welcome to the statistics behind racing. In today's episode, we're beginning chapter 1 of our journey into the interesting reality of motorsports racing. Not just racing as a sport, not just racing as an entertainment, but racing as a science, a language, and a relentless pursuit of human performance. Before we can understand racing strategies, vehicle engineering, driver psychology, or championship rivalry, we first need to comprehend one fundamental concept. What exactly is speed? And more importantly, how are we obsessed with it? Since the earliest days of historical civilizations, humanity has been intrigued by rapid movement of speed. From horses crossing vast landscapes of the mountain, to steam locomotives revolutionizing modern world society, to jet aircraft changing technological advancements, every generation has one breaking barrier: to move faster than the generation before. Speed represents freedom. It represents the progress of time. It represents the idea of challenging desirable intentions of obstacles. When a racer driving straps into a machine being able to reach over 200 miles per hour, they aren't simply operating the vehicle, they are participating in one of humanity's oldest determinations: to explore where the limits truly exist, and the limits are often pushed by force and pressure. Now, when most people think of speed as a numerical value of the distance traveled in miles per hour, kilometers per hour, a reading on the speedometer, but in reality, racing is much more complex than it actually is. In fact, the fastest car on paper does not win. The language of speed includes several interconnected components of motorsport history. That includes velocity, acceleration, momentum, traction, aerodynamics, reaction time, fuel efficiency, and control. Professional racing is about driving fast. It's about understanding the reactance of speed that can be managed without hesitation. Because true speed on a straightaway isn't created, it's established through a full lap, every corner, every brake zone, every throttle input, psychological thinking. Let's start with acceleration, for instance. Acceleration is the rate at which a vehicle increases speed throughout a lap time in circuits. In simple terms, how quickly can a machine of cars go from slow to fast? This is where power becomes very crucial towards current society. A race car producing massive amounts of horsepower is impressive, right? However, if that power can't reach the ground efficiently, it becomes pointless. This is why engineers obsess over traction systems, suspension geometry, tire compounds, and weight distribution. Because acceleration isn't simply an engine's fault, it's the system's problem. The driver feels this instantly, the moment the lights goes out, the moment the throttle is used up, the moment that physics is going under control of racing. Those racing friction of the speed of sound can determine victory or defeat. Momentum is one of the misunderstood concepts of racing. Momentum is the force created when mass moves over velocity rates. Remember, the greater the speed and mass, the greater the momentum increases. Elite drivers realize that maintaining momentum is important for obtaining maximum speed in racing. Think about racing in a circuit. A driver can charge aggressively into a consecutive corner, brake repetitively, and lose valuable momentum in the car's aerodynamics. Or they can float through the corner smoothly, preserving speed and carrying that energy onto the next straight corner. The second driver often wins the course taking the lead, not because they were faster, but because they lost the speed. And in racing, preserving speed is often more important than establishing it. One of the most fascinating aspects of modern racing is aerodynamics, the science of controlling airflow. At racing speeds, air moves similarly like a physical object. Every molecule made becomes a part of a conflict between resistance and performance. Engineers edit vehicles to monitor the drag while increasing the downforce applied to the tires to stick to the road surface more efficiently. Downforce regulates the amount of force that is applied to the circuits when lapping. The harder the tires press towards the asphalt, the more sufficient the grip will become, as the tires will stick to the road surface better. This creates a fascinating paradox. The quicker the race operates, the more handling it generates, allowing it to corner more efficiently. Modern racing technologies are not simply to be driving through the airflow. They are engineered around the air surrounding the car's performance record. People assume that racing is primary machinery, but the driver remains as the most important concept throughout motorsports. A professional racer repeatedly processes information at extraordinary speeds. Track temperature, tire wear rate, brake performance, competitor positioning, wind movement, grip leveling, mechanical feedback of the car. All of this information must be interpreted instantly as necessary for racing. At 200 miles per hour, hesitation starts exceeding the limits of cornering in motorsports. A 1 second delay can mean traveling nearly 300 feet before reacting. That's why ranked drivers create a superhuman ability to predict events before it can actually happen as the race begins. They're not usually reacting, they're always predicting before racing. To truly understand speed racing, you need to understand its vocabulary. Words such as slipstream, using disturbed airflow behind another vehicle to reduce air drag, apex, the most inner point of the circle of a corner while turning. Downforce, aerodynamic force pushing the vehicle towards the track while turning. The grip, the tire's handling to maintain surface conditions of the road during a circuit lap. Oversteer, when the rear of the vehicle loses traction before the front. Understeer, when the front tires lose grip and result in resistance overflow. Sector split, the measured calculations that estimate the status of the car completing a lap in a circuit. They're the language that drivers, engineers, analysts, and fans use to show performance. Learning this language allows us to see what racing is truly capable of and how it is important to the aspect of motorsport history. And how do drivers survive this tactic while avoid crashes the impact that the car may cause due to the chaos in my release. Allowing this strategy creates a sophisticated language for technical analysis to measure performance and precision that the car is truly remarkable of, for generating as a high conversation between driver, machine, and physics. Here's something very shocking. The ultimate goal of speed isn't racing. It's an efficient rate of speed. The champion isn't necessarily the person who drives the fastest. The champion is for the person who's wasting the least amount of time to come up with true strategies to mark the true generation of motorsports throughout reality. Every steering input, every brake application, every gear change, every throttle regulation, every pitting timeout, everything is measured. Everything is optimized for full storage of the car's hindered performance that teams can see truly about motorsports. Likewise, speed is defined as not a rate of winning, but a result of efficiency towards racing. As we end this chapter with the fundamentals of speed and understanding the core elements out of it, we have learned that speed is more than just a numerical value of a dashboard. It's a combination of physics, psychology, precision, and human decision making. Understanding the core feature of speed means understanding the acceleration rate of the car, momentum, aerodynamics, traction, reaction, tire conditions, control, and efficiency. These mechanisms help dive deeper into the rich understanding of the core movement of the car's ordinary performance in championships. In our next chapter, we will dive deeper into the machines that cars produce, the engineering masterpieces designated to challenge the offspring limits of what comes next to what is possible for cars to roll on wheels based on the handling mechanisms and the stress that people face during racing times. Until next time, keep learning, keep pushing your boundaries. And remember, racing isn't about speed. It's about the efficiency of anticipating what's going to happen next. As always, thank you for listening to this podcast. Until next time, see you in the next chapter.